Hey there! So today we'll be talking about recursion. Recursion is basically a simple concept in which a function calls itself to perform a task until that task has reached an end state. So let's get right into that. So I'll put this into smooth POV, and we'll first make something to actually work on. So we'll make an empty object, attach a component to it, go to data, value field, and let's put a string on here. Now, where do we have string? There it is, string. And let's call this A, B, C. Very simple example. We have a string called ABC, and what we want to do with that string is we want to generate this a slot for A, a slot for B, and a slot for C. Now, the way that we can achieve this is by first going into here again and creating an object that's going to be our array. This is where we want the ABC to actually be generated. And next, we'll actually make the slot that our generator is going to be on. And we'll call this simply recursion dash string. And I'll deselect. So, first things first, we'll need an actual source reference to the object we're working with. So we'll just grab it and create a source like this. Next, we'll need the first part for the recursion, which are called dynamic impulses. So we'll go to flow, dynamic impulse trigger, but specifically what we need is a trigger with data. So we'll just make one with Boolean and then put in the string here. So now we have a dynamic impulse trigger with data. This basically can call an impulse receiver with data in order to pass on its data. Next, we go back and we'll get an impulse receiver with data. Again, just to be fast. Oh, you're right. These don't auto-convert. For this one, we'll actually have to find the correct type on here. Am I blind? Oh, right. Strings are not values. I forgot. Strings are, in fact, objects, which is different from the inspector. There we go. So now that we have this here, we need to give this a name. So let's call this process. And then also put this in here. Our root for the execution is going to be the slot that we save the flux to, which is our target hierarchy. Oh, actually, I plugged this in correctly. I plugged the tag into the value. There we go. So now this is going to impulse onto this slot here with the tag process and its value, which will trigger the process over here. Now, first things first, we need to actually have a way to start the process and to actually iterate on it. So what we'll do is we'll get strings, and we'll get a substring. We'll get a substring here. Substring, put this in here. It'll output ABC. We'll want the length of 1. So we only get the first character. And then we'll also want a version that has a start index of 1. So that we get all of the remainder. And what we'll now do is very, very, very simple. We'll get an empty string here. Then we'll go to operators. and we'll need equals. Just get any equals, plug in the string, and now we'll know whether it's equal to an empty string. So if we up this to like 5, actually no, 5 won't work. Let's put the start index to something that isn't real. So for example, 9, which is out of range, which will display this empty string, which is equal to this empty string. Which should be exactly the same as when we finally run out of things to process. Now currently, we're directly substringing from the source over here, but if we're going to be iterating on this, we wouldn't be able to use this source without transforming it, so we'd have to write back to this field. But sometimes we don't want to modify the actual input data, because what if there's an issue when processing? What if we made a mistake? Now our actual input data is gone forever. So what we'll do instead, so we'll actually cut this part here. Also, sorry if I go quieter sometimes, it's because I'm moving away from the microphone a little bit. Since I'm not using the headset microphone right now, so we'll actually get a write, object write of type string. And there we go. So we'll hook up this value here and generate a store. Call this process string. The name doesn't really matter, but it helps us remember what it was. And we'll create another write that also references the process string for here. So now we have two things that modulate the process string here. Now, once we have that set up, we can actually go to work. Now, in order to make a new object, such as an empty, and give it a name, what we'll actually need to do is we'll need to make a template for this behavior. So I'm actually going to give this array a parent and give this here an empty by making an empty object. And it's just going to be our little template here for all of the empties that we're going to be generating. Next, we'll need to actually have a reference to that empty, like so. And we'll actually move our code a little bit farther out so that we have more space to work. Now, once we have this reference, what we can do is we can make a simple slot transform operation such as duplicate slot, which is going to happen exactly after the write each time. But just to make sure that we don't create an additional slot at the very end, because keep in mind, this is going to trigger after each circle completes. So if the circle already should break out of it, we need to check that at the beginning. So what we'll do is we'll actually go to flow and get an if, and that's going to be flowed into by all of these here. So next, we can actually remove this here from the substring, because this is our exit condition. Move it all the way over here. And now we actually have a way to know that our process is finished. So once this pings here, we know that it's done for working. Now, after duplicating the slot, we're almost a third of the way there. The next thing we have to do is we have to actually name the slot correctly. So, in order to do that, we'll have to get the one that has its length set to 1. which just gives us the first letter. And go to info, I think it was, set slot name. There we go. Grab the duplicate and give it its name. And we're almost finished, because all we have to now do is simply go to set parent. Our duplicate is the instance, and our new parent is the actual array over here. So we'll hook that up into the new parent. And we'll say do not preserve global offset, because currently, with how these are positioned, they're already at the correct offset anyway. Now, once we've done this, it'll basically generate a slot with the name A, but currently doesn't move on. What we have to do is we have to actually put the second substring here into the value up here, and then hook the parent, the set parent, into the impulse. So now our little circle machine is complete. What it'll now do is it'll process first what the actual name is it should give. It'll then make a duplicate and give it that name and parent it into our array. And then it will call itself again, make sure that we still have data to process, and repeat that. Now, when testing stuff like this, you have to be very, very, very careful, because if you mess something up, this will go infinitely. So always be very sure that your conditions are correct. And if you're unsure whether it's correct or not, what you can do is you can add a little piece of code in here that will actually just, all it'll do is it'll be a value increment of that integer, which will basically just make a number go up by 1 every single time the piece of code runs. It is also, I guess, your first little introduction into sanity checks, because this is basically just a minuscule sanity check to make sure that we didn't drop the ball somewhere along the way. So we'll just actually create a store here and call this I. Anyone familiar with programming will probably understand that this means iteration. But for those of you who have not touched programming before, that's basically what the I stands for, just iteration. So on false goes up here, and on written goes down here. And we'll add another if condition here. And what this is going to be, it's going to be a very simple check. Operators greater than, value greater than, integer. And we'll just ask, is I greater than 1,000? Or actually, in this case, since reasonably our amount of strings is like 3, we probably can lock it down to 100, just so we have less cleanup to do later. Then we just hook this up to here. Currently, this should say false, and it does. Good. Now, if you thought that I was going to run it now, you'd be mistaken, because we have one thing left to do, one very important thing, and that is make another write, specifically to I, because at the beginning here, we need to reset I. Otherwise, I is just going to continue iterating higher and higher and higher every time we run this, and eventually we won't be able to run it anymore because of this little piece of code here. All right, so before you can actually test the setup, you actually have to once pack it into the slot and then unpack it again, because otherwise these impulses here onto the slot will obviously not find the data it's looking for. But now that everything is parented underneath that slot, this little impulse receiver will be able to do its work. So we'll just impulse once, And you'll see over here we now have A, B, C. And yeah, that is literally how simple it is. You just have to make sure to remember these pieces here that we worked on today. We have the actual thing that is done every single iteration over here. So this is our actual thing that we do every iteration. Then over here, we have our recursion, where we go back to the function that we were just at before. Here, we have our checks to make sure that we should still continue our recursion, or whether we should escape the recursion. These are very important to be written correctly, otherwise you'll be looking at basically infinite execution. The earlier you can break out of the loop, the better, because any amount of processing done when you're already done with the work is just wasted processing time, essentially. And especially if you scale this up to something that does 1,000 to 5,000, like times the amount of work that this does, it is always good to preserve a little bit of processing. And our last part here is our initiator, which just stores the current data that we're working on. And yeah, that is pretty much it. I hope that this helps you in the future write some dynamic code like this. Some example of like application for this would be anything where you have a task you need to do repeatedly, such as we did today with the ABC, but it could also be parsing some JSON data, going down the hierarchy of slots, and then also going down those slots' children's. There's a lot you can do with this, and there's not much limits to what you really can do with this. Another thing you could do with this is you could check a child, then go up, then check that child, then go up when you're looking for something specific. So one example is if you have an avatar and you want to find the first slot that is between the avatar root and the armature, to find the first slot that is the parent of the armature and the child of the user root, parent root, avatar root, what you can do is you can first find the avatar root with checking the hips and then getting the root slot of that. This gets you the avatar root. And then from the hips, you check the parent of the hips. And if the hip parent slot is now your avatar root, you know that that is the highest slot above the avatar. However, if it isn't, you go one up higher. If that thing then has as its parent the avatar root, you know you're there. Now, the reason why you would want to do that is because it allows you to basically step through the pieces of the avatar that are between where the armature starts and the avatar root starts. This spot usually contains things like meshes. So if you're trying to make something to automatically set up context menu toggles, for example, you can use this behavior to easily automatically generate these context menus. But yeah, there's a lot more uses than this for it. As I said, uses are pretty much endless. It is something that is done a lot in programming, and I hope it helps you. Anyway, I hope you have a nice day. Bye-bye.